Can you hear me okay? Good. Before I actually introduce my topic, I'd like to relate it to skepticism. And if you look at the Australian Skeptics website, one of our first aims is to investigate claims of pseudoscientific, paranormal and similarly anomalous phenomena, meaning quackery and woo and all that crap, from a responsible scientific point of view. And you'll notice that I've got scientific in bold there. Now, recently, I've had a long career in science, but recently I've been studying the history and philosophy of science. So the question I ask, of interest to me, is where did these scientific methods come from? And I use scientific methods plural. There's a common misconception that there is a single scientific method and this is the way to do it. There are a range of scientific methods, but they're all based on rationality. And so I've looked into this question, and that's the question I'd like to try and answer today in my talk. Traditionally, until only a few hundred years ago, science was regarded as a branch of philosophy. It was called natural philosophy. And now I'm aware that there's been some criticism of philosophy recently by some prominent physicists, and I'm not here to talk about that, except to say, observe that if you look at this tree of knowledge and branches of philosophy, science rejecting philosophy is a bit like cutting off the branch of a tree or a child rejecting its parent. So I actually have a foot in both camps, science and philosophy, and whilst I might have earned my living from science over decades, unlike the previous Tim, I'm still only a student of philosophy. So I'm not going to talk about that. Eminent professors of philosophy such as Daniel Dennett and Massimo Pigliucci, who's also a former professor of science, have already responded to these criticisms at some length. And understand that my friend Peter Bowditch is going to have something to say about them here tomorrow morning. So here's what I'd like to talk about. I'd like to talk about basically three things: ancient Greek science, medieval revival of science, and in particular the development of experimental scientific methods. When we talk about ancient Greek science, we think of Aristotle, and there are his dates there. And amongst other things, he discovered logic. Now, I use the word discovered instead of invented because logic, I don't think it's something that's invented. It's something that is just there. And just as a bit of a side, the rules of logic are not arbitrary like the rules of the game of chess. They're not something that just somebody's invented. The rules of logic are there because if you break them, you are contradicting your own arguments. Breaking the rules of logic involves a self-contradiction. So the rules of logic are something that are just there. Aristotle discovered them. He didn't invent them. Now, whilst his physics may have been wrong, for example, he didn't know about momentum. And he led physics astray for about 2,000 years until overturned by Newton and Galileo. On the other hand, he did do some pioneering studies in botany, zoology, taxonomy and anatomy, but some of them were right, but some of them were wrong. And so we say that they were less wrong. So here's Aristotle's tree of knowledge that he actually wrote about. And he had this theory that you have irrationality, desire, sensations. Intellect was sort of more like, it's not what it means today. Over 2,000 years, the meanings of some words have changed in 2000. For example, the meaning of the word skeptic means something different to what it meant 2,000 years ago with the ancient Greeks. So he focused on rationality, which he thought was basically what philosophy was about. And then there were branches of the tree. This is art, more like in sculpture and things like that. Phronesis was sort of practical knowledge. Nous, you've all heard about nous. Intuitive intelligence, and then scientific knowledge. So he even 2,000 years ago, he saw science as something that came out of rationality. So, but to the ancient Greeks, science was simply a category of knowledge. These days, we tend to think of science as a rational method or a process for discovering knowledge about reality, but in the ancient Greeks, it was actually a category of knowledge because they didn't have a process. Herein lies the problem. It was knowledge of nature. So the acquisition of scientific knowledge was theoretical rather than experimental. Logic and reason, which they were really good at, was applied to observations of nature in attempts to discover the underlying principles influencing phenomena. But what they were weak about was the experimental side. They didn't actually do experiments, and they were good at logic and reason, but they were not good at empiricism. And that was their problem. And that's exemplified by some of the medical theories. I hesitate to use the word medical because this four humours stuff of Hippocrates, who's the so-called father of medicine, resembles quackery more than medicine. So in these ancient times, scientific experimental methods hadn't been developed, let alone clinical trials. Medical observations was largely confined to patients as individuals rather than as a cohort, as a group. Ancient physicians were not much better than naturopaths when it came to empirical evidence. Without scientific data from treatment groups versus control groups, it was difficult to know which treatments worked and which didn't. As a result, there was no clear dividing line between medicine and quackery. It was a bit like the lack of a clear dividing line between astronomy and astrology in those days. The so-called father of medicine, Hippocrates, tried to find the underlying causes of health and disease, but without much success, as you'll see by this nonsense of the four humours. As a result, he was better at prognosis than diagnosis, and often the best he could do was predict whether the patient was likely to die or recover. And if you predicted that the patient was going to die in a week's time and he died, they all thought, what a great doctor. He really knows his stuff. Aristarchus of Samos is an interesting character. The ancient Greeks they only had one name, so you identify them by where they came from, like Hippocrates of Kos. So on the plus side, it was actually the ancient Greeks such as Aristarchus of Samos, who was 1800 years before Copernicus, who first figured out the heliocentric or sun-centred model of our solar system. And in his diagram here, this is obviously not to scale, but at least he recognised that the sun, the earth and the moon were round objects. There's a myth that people thought the earth was flat. Educated people didn't think it was flat. They knew the earth was round, and Aristarchus even did some geometry and worked out his numbers were not right. He was a bit out, but he had the right idea of the relative. Well, not relative, but the sun was bigger than the earth, and the earth was bigger than the moon. That's all you can say. The really smart bloke was this one, Eratosthenes of Cyrene, who actually is an exception to this rule about not doing experiments, because he did a scientific experiment way back in the 3rd century BC, and he applied geometry to measurement of shadows about 840 kilometres apart, and he calculated the radius and the circumference of the Earth to within about 7 degrees accuracy. Now that's pretty good, and that was actually a brilliant experiment, and it worked way back those times. Yeah. Now we have to skip over the Roman period because the Romans were not renowned for being scientists. They were great engineers and inventors, and they invented some terrific things. And I won't read out all this list, but I'll mention kiln-fired bricks to replace the old sun-dried mud bricks, which were used and which are still used in some hippie communes. That some hippies are actually pre-Roman, but concrete. cast iron glassware underfloor heating. They used copper pipes under their concrete floors and had heated floors. I mean, it's just astonishing, some of the inventions that they came up with. A whole lot of steam power. They actually invented steam power and pulleys and cranes and so forth, mining technology and surgical instruments. Now, let's skip over the Dark Ages, because this is just one graph. It's only one piece of evidence, but the Roman Empire ended about here, and this is the output of manuscripts. Now, this is actually before printing. 15th century was before the invention of printing. But apart from the Carolingian Renaissance here, which was actually a small Renaissance under the emperors Charlemagne and Louis the Pious, who were interested in education and they promoted education, there was a small sort of renaissance of ancient Greek science and philosophy and educated stuff. Declined again. And then this rise here is basically due to the development of universities. Universities started about here, and the output of manuscripts, mainly non-fiction stuff, was mainly due to the rise of universities. So what happened during this period here, Western Europe, commonly called the Dark Ages, it actually lagged. We actually in Western Europe lagged behind the Byzantine and the Islamic parts of the former Roman Empire. Roman Empire split into three. Western Europe was one, the Byzantine and the Islamic parts. But from around 1050, Arabic, Jewish and Greek intellectual manuscripts started to become more available in the West in Latin translations. In particular, the translations of the ancient Greek works of Aristotle and others had a major impact on medieval European thought, mainly in philosophy, more so than science. And so you had in universities, you had the seven liberal arts, you had a trivium of grammar, dialectic and rhetoric, you had a quadrivium of music, arithmetic, geometry and astronomy. Music was regarded as a mathematical subject, curiously. And some universities offered professional courses in law, medicine or theology. Now, moving on to experimental science, one fellow that's not well known, Roger Bacon, I'm going to talk about in a minute, is Robert Grosseteste. He was the most influential scientist at the time. He was a leading English scholastic philosopher, scientist and theologian. After studying theology in Paris from 1209 to 1214, he made his academic career at Oxford, and he became the Chancellor of Oxford in 1234. He later became the Bishop of Lincoln, where there's now a university named after him. So Robert Grosseteste wrote about science. Scientia was the Latin name for scientific knowledge. And he read Greek, and that enabled him to translate some of the ancient Greek works. And in his first Latin commentary on Aristotle's posterior analytics from the 1220s, he described scientific knowledge. In this slide, he refers to the truth of the way things are by demonstration, that is, by empirical observation. Grosseteste himself went beyond Aristotelian science by investigating natural phenomena mathematically, as well as empirically in controlled laboratory experiments. He studied the refraction of light through glass lenses and drew conclusions about rainbows as the reflection of light through raindrops. Now, the main bloke was this one, Roger Bacon. He was a disciple of Robert Grosseteste, and although Grosseteste is credited with the idea of introducing the idea of controlled scientific experiments, there's doubt as to whether he made this idea part of a general account of scientific methods and for arriving at the principles of demonstrative science. This role fell to his disciple Roger Bacon, who was also an English philosopher, but unlike the bishop, he was a Franciscan friar. He taught at the Oxford Arts faculty in about 1247, and he moved to Paris. He didn't like Paris, and he made himself somewhat unpopular there, and so he went back to Oxford. And he did scientific experiments in optics, but he went beyond gross test work because he studied the physiology of the eye by dissecting the eyes of cattle and pigs. He did anatomy of the eye and the idea of lenses and focusing and so forth. He also investigated the geometry of light, thus further applying mathematics to empirical observations. Now, his major work, opus majus, which means major work, was written in 1267 CE, and there's a whole chapter which I've attempted to read. This is a quote from it, where he basically outlines the principles of experimental science, how to do experiments, how to isolate variables and control for various factors and so forth. So Roger Bacon, not to be confused with Francis Bacon, who was later, is generally regarded as the father of experimental science because it was he who set out the basic principles of how to do experiments. So he did further work on optics, and he investigated the nature and cause of the rainbow. He calculated that the measured value of 42 degrees for the maximum elevation of a rainbow. The optical experiments that both Grosseteste and Bacon conducted were of practical usefulness later on in correcting deficiencies in human eyesight, and the later invention of the telescope because of understanding about lenses and how light behaves going through lenses and so forth. But more importantly, Roger Bacon is credited with the originator of empirical scientific methods that were later further developed by scientists such as Galileo, Francis Bacon, Robert Hooke, etc. And I'm very pleased to say, I've got some take-home messages. I'll probably finish on time. So all I want to say is that science grew out of philosophy. Rather than being in conflict with philosophy, science is something that grew out of philosophy. The ancient Greek science used logic and reason rather than empirical experiments, and that's why they weren't very successful, especially Aristotle. The Romans were mainly engineers and inventors rather than scientists. The rediscovery of the ancient Greek texts gave rise to universities and then experimental science. Roger Bacon's contribution to science was greater than that of Grosseteste because he actually developed the methodological principles for experimental science for later scientists to build on. Now, if you're interested, this talk is written as an essay in the June edition of the Skeptics magazine, which is available out in the foyer, along with other editions. And can I say that this is a really good magazine to subscribe to if you're interested at all. So I think that's it. Are there any questions?